Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, good evening to everyone. Okay, so as usual, we'll begin the session with dua. Uh, okay, we begin session with dua for a non-Muslim on your own. For Muslim, we begin with Umul Kitab Al-Fatihah. Okay, so class, we continue with 8.3 continuity lecture. Wait, rasanya bukan ini kot. Okay. Okay, can you see what's been shared on the screen here right now? Nampak ke? Okay. So limit and continuity, we focus on the subtopic of asymptote here. Okay. So students should be able to find the vertical and horizontal asymptote and sketch the graph of rational function involve the vertical and horizontal asymptote. Okay, so a line, okay, vertical asymptote is a line for the graph, okay, is a vertical asymptote for the graph of y equal to fx if either, okay, the limit of x approach to a equal to positive infinity, or limit of fx approach to a from left side equal to positive or negative infinity. Okay, so we're going to recall the method of direct simplify, factorize, and or multiply by the conjugate. Okay, so okay, as we know that when we have a function of fx equal to 1 over x, okay, so we have x-axis and y-axis, okay. For a function of 1 over x, we're going to have a function of, okay, so for example, when x equal to 1, so then 1 over x equal to 1. When x equal to 2, so 1 over x or 1 over 2 equal to 1 over 2 or 0.5. When x equal to 3, then 1 over 3 is, okay, this is 0.5 and this is 0.33. So by looking at this one here, when x equal to 1, when x equal to 1, 1 over x or fx, fx equal to y. Let's say fx or y here, 1 over x. So when x equal to 1, so y equal to 1, 1 here. And then when x equal to 2, when x equal to 2, then y equal to 0.5. And when x equal to 3, y equal to 0.33, getting smaller and smaller. So recall, and let's say when x equal to 1 over 2. Okay, let's say this is origin point of 0, 0, and this is 1. So there's a value in between 0 and 1, which is 0.5 or 1 over 2. Then 1 over x equal to 1 over 2, or it is equal to 2. So it's equal to 2 here. So the graph sliding down, approaching to the line of x-axis. Okay. Same thing goes to when x equal to negative 1, negative 2, and negative 3. So when we substitute the value of here, the difference here is this is all positive. 1, 0.5, 0.3, 2. But then this one here, we have negative. And the graph will be something like this. Okay. Okay, now this is the graph of 1 over x, and the domain is all real values of x except when x equal to 0, which is negative infinity until 0 union 0 to positive infinity. Okay, so vertical asymptote, the values of x that will make the function undefined or when x equal to 0. Okay, and when x approach to 0 from left side, then we have here then. So therefore, x is equal to 0 is the vertical asymptote. This one is gonna be something like this. The graph when x approach to 0 from right side. Okay, we call the graph should be something like this. And look at this one here. The movement approach we call when x approaching to 0 from right side is sliding. We call is moving up here. Dia naik ke atas. And then when x approaching to 0 from left side, then the graph sliding down. Okay, sliding down like this. Okay, approach to negative infinity. Okay, so horizontal asymptote. Okay, a line of y equal to b is a horizontal asymptote for the graph if either fx equal to, we call x approach to negative infinity equal to b, or x approach to positive infinity also equal to b. Okay, we divide with the highest degree of x from denominator. Okay, so according to this one here, when x approach to positive infinity equal to, we call, which is equal to 0 here, and also then here when x approach to negative infinity, then fx approach to we call getting close to 0. So class, x-axis is where the value of y equal to 0. So look at this graph here now. It's sliding down, approaching to the line of x-axis. Dia semakin hampir dengan paksi x. And also from here, is we call moving, we call getting close to the value, the x-axis. So this is a value where this is a movement where the graph approaching to the x-axis or y equal to 0. So we combine both of vertical and horizontal asymptote for the example we call for the example of 1 over x just now. Okay. When x approaching to 0 from left side and when x approaching to 0 from right side here, then fx approaching to positive infinity. The graph is what we call moving up and the graph sliding down. Okay. And when x approaching to infinity, fx approaching to 0, and when x approach to negative infinity, fx approach to 0. So we are going to combine all these four, okay, all these four elements, 1, 2, 3, 4, and make the, we call the complete graph to show that there's a horizontal and vertical asymptote. Okay, and for this one here. So look at this, the graph sliding down, approaching to the goal, getting close to the line of x-axis or where it is equal to 0. And this is the y-axis, or actually that y-axis is also where x equal to 0. Okay, so I'm going to come up with a few examples that make the, we call my explanation clear. Where this is the first or the beginning of the, we call introduction of vertical and horizontal asymptote. Okay, find the vertical and horizontal asymptote of fx equal to 1 over x where x cannot be equal to 0. Okay, class. When they give you, when you get a question of to find the vertical and horizontal asymptote, and the function is a ratio, a fraction, pecahan. Okay, 1 over x square. A function where it's a fraction, pecahan, or ratio, nisbah. Okay, from the denominator, it will give us two things here. Okay, from denominator, it will give us two things. The first is the domain of the function, and automatically denominator also tell us what is the vertical asymptote of the graph. Okay, so because from the denominator, it will give us we call the domain where x cannot be equal to 0. X squared cannot be equal to 0, so then x cannot be equal to 0. Okay, so the domain of this function is from negative infinity until 0, union 0 to positive infinity. So that is the first information that we'll get from the denominator. And second information here is the vertical asymptote menegak, where from here we make a conclusion that the vertical asymptote is x equal to 0. Okay. Hold on, ada yang masuk baru masuk. Okay, so this is the one now. This is it. So from denominator, it will give us two information. The first is the domain and vertical asymptote. Okay, so the domain is from negative to positive infinity except when x equal to 0. And the graph, okay, where x cannot be equal to 0. Look at this one here. From negative to positive infinity except when x equal to 0. So x equal to 0 is along the y-axis. This is where x equal to 0. Okay. So when x approach to positive infinity from the left and right, okay, the graph I call kita kata bergerak ke atas, moving up, approach, we call getting close or approach to the line of y-axis or fx here. And vertical asymptote 1 over x squared for what we call approach to positive infinity. And horizontal asymptote when x approach to negative infinity. For example here, for this one, just imagine that if x equal to negative 10, so 1 over x square, which is 1 over negative 10 square, equal to 1 over 100, where 1 over 100 equal to 0.01. So this, recall, this graph will move approaching to line of y-axis. Okay. Okay, the graph move approaching to the line of y-axis here. Okay, so we're going to combine these two graph, these two lines into one, into a complete graph. Okay, so the graph will something like this, moving down and sliding, approaching to the line of x-axis, and same to goes to this line here. Sama macam ni juga. The graph will move approaching to the line of x-axis to the right side. Okay, so this is the graph of 1 over x squared. Okay, there you go. So this is the graph of 1 over x squared. Okay, so then determine the asymptote of 1 over x squared plus 5x minus 6. So class, can we factorize this? So where x squared plus 5x minus 6, we call factorize this, now become x plus, no, sorry. Okay, x minus 1 and x plus 6. X multiplied with x squared, x times 6, 6x minus 1x equal to 5x. So negative 1 multiplied with 6 equal to negative 6. Okay, so guys, girls, from denominator, I told you just now, it will give us two information. The first is the domain of the function. Domain of the function, and second is the vertical asymptote. The domain of this function is all values of x. Okay, from here, where the denominator cannot be equal to 0. So then x cannot be equal to 1 and x cannot be equal to negative 6. So that the domain of this function here is negative infinity until negative 6, union negative 6 until 1, union 1 to positive infinity. And vertical asymptote is where x equal to 1 and x equal to negative 6. Okay, so automatically you will get two information from the denominator where it is a domain, and the second thing here is the vertical asymptote. So that is the domain then. Sketch the graph of the function. Okay. Wait. Okay, class. This we have 1 over x squared plus 5x minus 6 just now. Okay. When x equal to negative 6, x equal to negative 6, and x equal to 1. X equal to 1. Okay. So then when x approaching to negative 6 from left. Okay, just imagine that this is negative 6, then we have negative 7, negative 8, negative 9. Okay, so let's say the movement of x from left approaching to negative 6. Okay, negative 10, negative 9, negative 8, negative 7. Okay, between negative 7 and negative 6, there are negative 6.5, negative 6.2, negative 6.1, negative 6.01. Okay, class, just imagine that if I substitute with negative 6.01 square plus 5 times negative 6.01 minus 6. Okay, can anyone tell me what is the value of this? 1 over x squared plus 5x minus 6, where x I choose on my own, that recall the value of x that very close to negative 6, put negative 6 from left. Negative 6.01 square plus 5 times negative 6.01 minus 6. Can anyone tell me what is the value? What value that you get then? Anyone? Hello, class. Are you there?
Ada, sir.
Okay. What if I choose a value of x that very close to -6 from left? Example, -6.01. Can anyone tell me what the value that you'll get here?
0.071701.
0.071. Sure. Okay, you may substitute -6.01 here and here, or if I choose using the x squared plus 5x minus 6, what will get here then? Okay, for example, 1 divided by -6.01 bracket square, okay, plus 5 times -6.01 and minus 6.
Dapat negatif, sir.
Negative or positive?
Negatif.
Okay, the sign here is positive. Just to see whether it's a positive or negative.
Saya dapat positif, sir.
Positif berapa?
14.27.
14. Okay, wait. If I use the x plus 6 and x minus 1, negative 6.01 plus 6 and negative
Itu, sir. Dapat
6.01
positif 14.27.
minus 1. 14.265 kan?
Ya.
Okay. Okay, 14 is not very a big number, but then it tells us that the value is positive. Okay. So let's say if I substitute with another 0 here. Okay. If I choose 1 over negative 6.001 square plus 5 times negative 6.001 minus 6, then for this one I will get 142.836. Okay, 142. This quite it shows we call a big number, and it's all positive, so that's why it's a positive infinity. Okay, class. Actually, in your real examination, we just like to see the sign of positive infinity and negative infinity. This calculation that you make this in other papers, kertas contengan. Okay, and for this one is just okay. For other topic, you will substitute the value of x and make a calculation, expand, simplify until you get the final answer. But for limit and continuity, we don't need this actually. We don't need this calculation actually. We just need to see whether the student come up with a positive or negative infinity sign. And because finally, we want the student to sketch the graph of this function. Okay. Let's say Okay, class. Let's say if I substitute, okay, x approaching to -6 from right, we got negative 0, -1, -2, -3, -4, -5. Between -5 and -6, they are -5.5, -5.8, -5.9, -5.99. So let's say if I substitute with -5.99, negative 5.99 here. Okay, what we'll get then? Okay, what we'll get then? Class.
Negative 14.306.
Okay, negative 14.306. What if I add another 9 here? Very close to -6 from right side.
Negative 142.
Negative 1. Okay, negative 142 point something. So it's a big number here with negative. So that's why we come up with a sign of negative infinity. Okay, next. When x approaching to 1 from left, meaning from 0, 0, 0.5, 0.8, 0.9, 0.99, 0.999. Okay, let's say 0.99 plus 6. Okay, sorry. Okay, so 0.99 and 0.99. And what about this one here now? Okay, class, what about this?
Negative 14.3.
Okay, negative 14. If I add another 9 here, then it become negative 142.87 and so on. So it's negative big number here. Then we come up with a sign of negative infinity. And when x approach to 1 from right side, so from 4, 3, 2, and in between 2 and 1, we get 1.5, 1.2, 1.1, 1.01, 1.001. Okay, if I choose the value of 1.01, 1.01. What will get then? Class, what will get then?
14.26.
14. 14 ke 16? Oh, 1.01. Sorry. Okay, 14. Okay, let's say I'll test with 1.001. What about this? 1.001. 1.001. Come on.
142.
Okay. 142.836, so on. So it's big number with a positive sign here, then we come up with a sign of positive infinity. Okay. So for vertical asymptote, okay, it's clear. We have found out the limit when x approach to 6 from left and right, x approach to 1 from left and right. Okay, now limit x approach to positive infinity is a 1 over infinity or approaching to 0. So then the horizontal asymptote is y equal to 0 and the vertical asymptote is negative 6 and 1. Okay, now it's time for us to sketch a graph of this. Okay, I prefer to sketch it live here with you rather than I just click the button. Okay. Hope that is we call this graph clear to all of you then. Okay. So 1 over x minus 1 and x plus 6, where x, okay, the denominator here, this is x equal to negative 6, and here is where x equal to 1. And then this is for horizontal asymptote where y equal to 0. Okay, so now okay, the first positive infinity, x approach to negative 6 from left, positive infinity, x approaching to negative 6 from left, positive infinity. Okay, what's next? X approaching to negative 6 from right, negative infinity. Okay, and x approaching to 1 from left, negative infinity. Okay, and then x approaching to 1 from right, here positive infinity. There you go. Okay, now this is the graph. Okay, for some cases we need to find out where at what point that this graph cut the y-axis. So when the graph cuts the y-axis, okay, when the graph cut the y-axis, okay, then x equal to 0. So just imagine that if x equal to 0 and x equal to 0 here, what will we'll get then here? 1 over negative 6. So this is the cutting point here where the value of y is negative 1 over 6. Okay, so this is a graph. This is how the graph looks like. Look at this one here. Okay, and also this one here. Okay, so this is the we call condition. This is a condition. This is a situation where it's a vertical, horizontal asymptote. Okay, where the graph is getting close to the line when x approaching to negative infinity and when x approaching to positive infinity, this line will getting close to the line we call get close to the x-axis, but it won't touch or cut the line at all. Dia takkan sentuh dia takkan sentuh ataupun potong paksi x ni. Okay, so this is the condition where is a horizontal asymptote. Graf ni akan berterusan sampai bila-bila pun, dia sekadar menghampiri sahaja. Okay. Okay, never mind. Yang redundant tu benda yang sama sebenarnya. Okay. Now determine the asymptote of x minus 1 and x square minus 1. Okay, from rough picture, we might think that this is an x minus 1 divided by x minus 1 and x plus 1. Okay, we'll see. Okay, that's it. X minus 1 divided by x minus 1 x plus 1, where x cannot be equal to positive and negative 1. So this is our reference here now. Then x cannot be equal to positive negative 1. And from here also, it will tell us the domain and the vertical asymptote. Okay. So this is the domain. So then when x approach to negative 1 from left, this is negative 1 and this is 1. Okay. When x approach to negative 1 from left, so just imagine that from negative 3, negative 2, negative 1.5, negative 1.2, negative 1.1, negative 1.01. Okay. So when x is getting close to 0, okay, 1 divided by plus 1. Let's say when x approach to negative 1 from left, from negative 3, negative 2, negative 1.5, 1.2, 1.1, negative 1.01. For example, so negative 1.01 plus 1 equal to 1 divided by negative 1.01 plus 1, negative 0.01. Am I right? Betul tak?
Betul, sir.
Betul. Okay. Negative 1.01 plus 1. Okay. So we change the, okay, we simplify this. You will get negative 100. So look at this one here now is negative infinity. When x approaching, okay, this is 0. When x approaching to negative 1 from right, 0, negative 0.5, negative 0.8, negative 0.9, negative 0.99. Okay, when x very close to negative 1 from right side, negative 0.99 plus 1. What will we get then? Negative 0.99 plus 1,
0.01.
0.01. So simplify this, you will get 100. A big number, positive. So you will get positive infinity. And when x approaching to 1 from left, x approaching to 1 from left, 0, 0.5, 0.8, 0.9, 0.9, 0.99 here. Okay, if I substitute with 0.99 plus 1, what you will get then? 0.99 plus 1, which is 1 over 1.99, right? And this one very close to 2. So that's why we have 1 over 2 here. And then when x approaching to 1 from right, from negative 2, 1, but no, 2, 1.5, 1.2, 1.1, 1.01. So 1 over 1.01 positive plus 1. It looks like something like this, 2.01. Very close to 1 over 2. Okay. And then, okay, x1 is not the vertical asymptote. Why? X equal to 1 is not the vertical asymptote. Why? Because where we call it does not give us a value, or it does not give us the answers of is either positive or negative infinity. Dia memberikan nilai jawapan yang hampir kepada satu nilai, which is 1 over 2. So x equal to 1 is not the vertical asymptote. Do you realize that from here, x minus 1 divided by x squared minus 1, then x minus 1 divided by x minus 1, and x plus 1. Clear this. It will give you 1 over x plus 1. Do you realize this? Okay. So that's why x equal x plus 1 did not give us that we call the vertical asymptote. Okay. So the vertical is asymptote is only one, which is x equal to negative 1. So then horizontal asymptote, okay, for x approach to positive or negative infinity. So for this one approaching to 0. So horizontal asymptote y equal to 0. For this one here. Okay, now by sketching the graph, there's only one vertical asymptote where x equal to negative 1, one vertical asymptote and one horizontal asymptote, and this is the graph. Fx equal to 1 over x plus 1. Okay. Get it? Boleh ya? Okay, tak apa. Because this video is recorded, so you can just copy out later. Or you may just snapshot from your screen, Navico, from your device, or snap a picture of this. So determine the asymptote of fx equal to natural log of x. Okay, when x approach to 0 from positive of natural log of x equal to negative infinity, so x equal to 0 is a vertical asymptote. When x approaching to 0, okay, this is 0, when x approaching to 0 from right, okay, and natural log, okay, between 1 and 0, between 1 and 0, let's say if I choose the value of x equal to 1 over 2. So natural log of 1 over 2 You may just get it from your calculator. Natural log of 1 over 2. It gives us a negative 0.6931. Okay, the value is negative. When x equal to half, then the value of y is negative. So the graph sliding down something like this. Okay. Okay, so something like that. Something like that. We call the graph sliding down. So no horizontal asymptote. Okay. And determine the asymptote of fx equal to e to the power of negative x and sketch the graph. Okay, so class, for this one, as we know that the graph, this is the graph of e to the power of x. Okay, so there's only one asymptote when x approaching to negative infinity and the graph approaching to 0 or x-axis. So vertical asymptote, no vertical asymptote, and horizontal asymptote when x approach to negative infinity. Okay, y equal to 0 here. Okay, this is e to the power of x and this is e to the power of negative x. So when x approach to negative infinity, negative times negative equal to positive. So e power of big numbers equal to big numbers. So that's why the graph moving up. Okay, and when x approach to positive infinity, so 1 over ex, this one here, e to the power of negative infinity, then approaching to 0, menghampiri kepada paksi x. Okay, now what about this? As we know that I told you just now, denominator will tell us, okay, the domain of this function and the vertical asymptote, where square root of x squared minus 4 cannot be equal to 0. Okay, so if we square left and right, it also x squared minus 4 cannot be equal to 0. And from here, we have x minus 2 and x plus 2 also cannot be equal to 0. So class, what is the domain of this function? What is the domain of this function? Negative infinity until negative 2, union negative 2 until 2, union 2 to positive infinity. And what is the vertical asymptote of this graph? Vertical asymptote of this function? Anyone?
X equals to negative 2, x equals to 2.
Good. Thank you very much. X equal to negative 2 and x equal to 2. So the domain. Okay, class. Wait. Um. Dia make a mistake from -2 until 2. Saya ada tersilap sikit ke? Sekejap kan. Saya cuba tengok sekejap. Saya ada tersilap tafsir ke tadi? Silap cerita ke tadi? -2 and 2. Oh, yes, yes, yes. Okay, class, I make a mistake here. May call mistake explanation here. Because let's say from -2 until 2. So let's say if I choose x equal to 0, so we have 0 minus 2 and 0 plus 2. Okay, so it's going to be 0 minus 2 equal to -2 and +2. So it gives us -4. And square root of -4 is undefined when we talk about real numbers. Okay, sorry guys, girls. I make a mistake here, sorry. So look at this. I'm a bit call has tak perasan yang saya define incorrectly for this one here. So okay, for square root of here, for this where x okay, because as we know that square root of fx, okay, f square root of x fx, where fx must be greater than or at least equal to 0. But because from denominator cannot be equal to 0, so from here we clear the sign of equal then, only greater than. Okay, class. I re-explain here. So for 2 divided by square root of x square minus 4, as we know that the denominator cannot be equal to 0. But if we take this function of x square minus 4 separately, kalau kita asingkan ini saja, as we know that for this one, x square minus 4 is greater than or at least equal to 0. Okay. For the domain of square root function is greater than or equal to 0. But then because the denominator cannot be equal to 0, then we clear the sign of equal. So we only have the sign of greater than only. Okay. So this is the domain of this function, negative infinity until -2 and 2 to positive infinity. Okay. Okay, make a correction then. I'm sorry for my mistake just now. Saya pun tak perasan tu. Okay, then for vertical and horizontal asymptote, it's because just now we agree that is from -2 and 2, greater than and less than. This one here. So the whole of this represent in number line, we have -2 and 2. Okay, post greater than and less than, and less than and greater than. Okay. So when x approaching to -2 from left and x approaching to 2 from right, x approaching to -2 from left here and x approaching to 2 from right here. So then we substitute the value of x that very close to -2 from left side. So from -4, -3, -2.5, -2.2, -2.1, -2.01. So then 2 divided by square root of -2.01 minus 2 and negative 2.01 plus 2. What we will get then for this one? Class, substitute x with negative 2.01 here. Let's test let's test together what the value of this. Okay. Negative 2.01 minus 2 and negative 2.01 plus 2. What will you get then, class?
9.9.
9.98. Okay, good. Adding up with 2.001. 2.001. Okay. Tell me the result of this.
31.6.
31.6. Okay, good. And you may also test when x approach to 2 from right. So from 4, 3, 2.5, 2.2, 2.1, 2.01, 2.001. You substitute here 2.001, 2.001 here. Come on, class. What you get then? 31.6, right?
Yes.
Okay, good. So both give us, we call the positive and positive infinity. So the vertical asymptote is an x negative 2 and x equal to 2. And for this one, limit x approach to negative infinity, substitute with the highest degree of x from denominator. Okay, so let's say we divide by x. 2 divided by x square. Okay, 2 divided by x divided by square root of x square divided by x square minus 4 divided by x square. Limit x approaching to positive and negative infinity here. Okay, so this one approaching to 0, this agree with 1, and this approach to 0 here. So 0 divided by square root of 1 minus 0 equal to 1 divided by 0 divided by 1 equal to 0. So the horizontal asymptote is y equal to 0. Okay, let's see the graph now. Let's see how the graph looks like. Okay, so that is the vertical asymptote of x equal to negative 2 and x equal to 2. Okay. There you go. Okay, boleh ya? So this is a graph of 2 divided by square root of x squared minus 4. Okay, so the conclusion here, which I think that you can just simply read the we call the lecture notes by yourself. Okay, so when positive value divide by 0, we're approaching to positive value here, it is positive infinity. Okay. Ini ada dalam nota ke? Yang keempat-empat ni? Yang ini? Okay, negative value divide by negative 0 from negative infinity. For example, negative 2 divide by from 0 from left side. Negative 0.01, negative 0.01. Negative divide by negative, that give you positive. Okay. And of course, positive value divided by negative value equal to negative infinity, and negative divided by positive equal to negative infinity. Okay. Okay, class. I think that we just simply continue with part 4. Would you like to take a break, or can we just continue our discussion on part 4 here? Class. Nak rehat dulu ke? Hello? Lama. Ada orang ke tak ada orang ni? Hello? Anybody home? Kelas?
Ada, sir.
Nak teruskan ke dah rehat jap? Teruskan. Oh, rehat kejap. Okay. Take 3.
Sir, mute.
Okay, sorry. Okay, the function is said to be continuous if its graph can be drawn each over interval of its domain with continuous motion, okay, of the pen without lifting the pen. So for example, if I have this, okay lah, saya ingat pula. Okay, so let's say if we have a graph here where x equal to a, and then we have a graph this side. Okay, here. So just imagine that if I begin my sketching or my journey from here, okay, the graph, okay, look at this dot moving on the line of this graph smoothly until I reach the point of x approaching to a from left. Then I need to leave a pen and jump to this point and continuing. So last time, okay, in the previous topic, we look into a limit of x approaching to a from left of the function fx equal to an L. And then limit of x approach to a from right side of the function fx equal to an m. And okay, the limit fx x approach to a from negative side is exists, okay, and it is v equal to L, and limit fx when x approach to a from the right side is also exists, wujud, and the value of y equal to an m, and let's say L is equal to an m. The value of L and m actually are one value. So we come up with a conclusion that limit of this function x approach to a exists. Okay, so 1, 2, and 3. Okay, limit x approach to a from left of the function fx equal to limit of x approach to a from the right side of the function. If the limit from a limit of x approach to a from left exists, limit x approach to a from right exists, and the limit of x approach to a from left equal to limit of x approach to a from the right side, then we come up with a conclusion that the limit of fx exists. So 1, 2, and 3. So in this topic of subtopic of continuity, we are going to look at this 3 again, and we add with another what we call another condition when f and x exactly equal to a and the value of y equal to L. Okay, L, this one here, L equal to an m, and then fx equal to a also equal to an L. So means that here, okay, this is the graph when x approaching to one value of a from left, okay, and when x approaching to one value of a from the right side, and when x exactly equal to an a, and it gives us the one value of y equal to an L. So, girls, look at this. Look at this this dot, okay, moving clearly, okay, smoothly, and when x reach at the point of x equal to a, dia tak perlu nak alih-alih pen. Straightly dia boleh terus, okay, move forward then, okay, without lifting a pen. Something like this. Okay. When x equal to a, and then here, look at this. Okay, look at this movement dot, blue dot here. Okay, it moving on this line. Dia bergerak atas garisan ni, but when it reach x equal to a, it jump here and then jump to this point and continue up the journey. So this is not continuity. Okay, continuous maksudnya berterusan. To be continue, akan bersambung. So continuity dia bersambungan, berterusan. Tak ada apa yang menghalang pergerakan graf tersebut. Okay, so this is continuity. And this is not continuous. Okay, so this is not continuous, this is not continuous, this is continuous. Okay. So look at this one here. Look at the graph. Okay. Then, okay, class. Meaning in this graph, it all continuous at all value of x. Dia selanjar ataupun bergerak dengan lancar di semua nilai x equal to a. Okay. Continuous. And this one also continuous. Okay, tak ada yang putus. And what about this? Look at this. Okay, on left side, we call dia bergerak, we call move smoothly, but then we need to shift a pen above them, jump the pen above them, and sketch another part of the graph. Okay, so this is not continuous or discontinuous. And what about this one here now? Okay, dia tak bersambung. So on left side and jump to the other side and sketch it on the right side then. So this is discontinuous. And what about this one here now? Okay, sketch on left side, then the pen jump for a dot, and then the other side. So this is discontinuous. Okay, so we sketch on the left side. Okay, then when x equal to a, then the point jump to on the other side. There you go. Okay, something like this. Okay, continuity of function at the point a. A function is to be continuous at x equal to a if and only if this condition is applied or fulfilled. Fa defined, limit x approach to a defined, exists, and this one here. Okay, so class, we have talked about this in lecture 2. Okay, what is the condition for the limit exists? Class, can anyone refer to your lecture notes? What is the condition for the function or for the limit exists? Hello, ada orang lagi tak? Hello, kelas. Rasanya semua tak ada depan komputer ni. Hello, anyone? Masih ada ke? Ke semua dah gaib dah?
Ada, sir.
Ada. Okay. This one, okay, please refer to lecture part 2. For the limit exists, limit of fx, x approach to a from the left side equal to limit of fx, x approach to a from the right side. Okay. And we just add another one condition here, substitute x equal to a into fx. So if the limit fx, x approach to a equal to f when x is exactly equal to a, then we said that we call the function is continuous at x equal to a. Okay, so determine whether the function fx is continuous at all these points here. Okay, continuous. So before we determine whether the function is continuous or not, fx must fulfill the condition of limit. Okay, syarat limit mesti dipenuhi dahulu. Then tambahan syarat fx equal to a, kalau sama, then it is continuous. So when x equal to -2 here, limit x approach to -2 from left equal to 1. And when x approaching to -2 from right, okay, x approaching to -2 from left here equal to y equal to 1. And when x approaching to -2 from right, then approach we call the value of y equal to 2. So does the limit exist? Does the limit exist? Class? Limit x approach to -2 from left of the function fx. Limit x approach to -2 from left, y equal to 1. And the limit of x approaching to -2 from right of the function fx equal to 2. So guys, girls, the limit x approach to -2 from left exists, wujud. Limit x approach to -2 from right exists, which exists. But then the value of y, 1 and 2, they are not equal. So does the limit exist? No, the limit does not exist. If the limit does not exist, then for this question, we said that this is discontinuous. Okay, tidak selanjar. Okay, when x approach to 0, from left, the graph moving up to positive infinity. And when x approach to 0 from right, the graph moving up approach to positive infinity. Okay, does the limit exist? It is undefined, right? So then for this one here, it is discontinuous. Okay, when x equal to 2, limit x approach to 2 from left of the function fx. Look at this one, x approach to 2 from left, and is approached to one value of y, which is equal to 2. And when x approach to 2 from right side of the function fx, look at this. Okay, and also it shows us that we call it approach to one value of y, which is equal to 2. Okay, my question to you, does a limit exist for this case? X equal to 2?
Exist, sir.
Okay, limit exists because both of these limit exist from left and right, and the limit from left and right are equal. Limit x approach to 2 from left, fx equal to limit of x approach to 2 from right, fx, which is 2 and 2. They are equal. Okay, let's say when I substitute x with 2, here, exactly here, and the value of y also equal to 2. Okay, limit x approach to 2 from left, x is equal to 2. Limit x approach to 2 from right also exists, which is also equal to 2. And limit from x approach to 2 from left side equal to the limit of x approach to 2 from right side of the function fx. So then the limit exists. And when the limit exists, when x is exactly equal to 2, also give us the y equal to 2. Then this function is fx is continuous. Okay, at x equal to 2. Okay. So only for C, it is continuous at this moment. And let's take a look at this. When x approach to 3 from left, limit x approach to 3 from left of the function fx. Okay. Let's say if I put the value of y here equal to 3. Okay. So limit x approach to 3 from left equal to 3. Limit x approach to 3 from right. X approach to 3 from right. Okay, it we call shows that we call one value of y, which is also equal to 3. Okay, limit from a left and limit from right exists, and both are equal, which is equal to 3. Then limit x approach to 3 of the function fx exists. Okay, the limit exists. Right now, when x is exactly equal to 3, then y equal to 2. f3 equal to 2. And they are not equal now. So limit exists, but then when x exactly equal to 3, y equal to 2. So does this function fx continuous at x equal to 3? Dia selanjar ke tidak? Class, this graph continuous at x equal to 3? Hello? 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 Mana game Manchester United? Masuk gua ke? Hello? Class, is this continuous at x equal to 3?
Yes.
No, it is not continuous. Okay, the limit exists, but when x exactly equal to 3, y equal to 2, and they are not equal. So it is not continuous at x equal to 3. Only continuous at x equal to 2 here. Okay, it does not exist. The first one, when x approach to -2 from a left and right. Okay, 1 and 2. The limit does not exist. Okay, is undefined. So it's not continuous at x equal to 0. When x approaching to 0 from left and right, they are we call to positive infinity, is dia tak bersambung langsung. And for this one, when x approaching to 2 from left and 2 from right, okay, both give us the same value. And when x exactly equal to 2, then y equal to 2, then it's continuous at x equal to 2. Okay, the limit exists when x approach to 3 from left and right. So the limit exists. But when x equal to 3, it's not equal to 3 anymore, but then it is equal to 2. So fx is not continuous at x equal to 3. Okay, determine the point where the function is not continuous. So guys, girls, the fx is not, the function is not defined at x equal to 1 and x equal to -2. So F1 and F negative 2 does not exist. Okay, for this one here, which I think that we look into yang kuliah sebelum dia. Okay, from denominator, we know that X we call cannot be equal to 1, and here X cannot be equal to negative 2. Negative 2 and 1. the graph the graph might be something like this one here and here, for example. So you can see here it is the positive infinity and negative infinity, and positive infinity. None of them is combined. Tak ada yang bersambung langsung. So at x equal to 1, x equal to negative 2, we call it is not continuous. Okay. So what about this one here now? Sketch the graph and determine the continuity. Okay. Class, which I think that I'll only show you one of the graph here. Okay. So if I sketch this graph separately, okay, as we know that this is the graph of x squared plus 2x plus 1, it's going to be like this. Okay. So this is the graph of x squared plus 2x plus 1. But then, because we limit the domain for x less than 0 and start from here to here. So, what are we going to do with this one here now? There you go. So, from here to here is the graph for x squared plus 2x plus 1. And for x plus 1, so y equal to x plus 1. When x equal to 0, y equal to 1. And when y equal to 0, x equal to negative 1. So 0 and 1 here, and negative 1, 0 here. So this is the graph. Okay. But then because this is only valid for x greater than 0, okay, start from here. So what are we going to do with the rest of the graph? Clear them all. That's it. So combine between this, and you get it all here for x plus 1. Okay. So at x equal to 0, f is continuous at x equal to 0. Why is it continuous? Okay, I move this. Okay, look at this blue dot here. I move the graph through the red line. Okay. And when it reach x equal to 0, I can just continue my journey. Okay, without need to lift out the pen, tanpa perlu mengangkat pen pun. So it is continuous at x equal to 0. Okay, sekejap. Saya cuba padamnya tu. Okay, the domain is continuous. The domain is continuous motion of the pen without lifting the pen. Tanpa perlu kita mengangkat pen. Okay, what about this one here now? Okay, the denominator cannot be equal to 0. 3x minus 6 cannot be equal to 0. Then 3x cannot be equal to 6. And x cannot be equal to 6 divided by 3 equal to 2. So that's why we come up with the vertical asymptote VA, which is x equal to 2. Okay, so we sketch the graph x approaching to 2 from left, and when x approaching to 2, okay, x approaching to 2 from right, and x approaching to 2 from left. Okay, so the next graph here. So class, does recall this graph continuous at x equal to 2? Dia bersambung, berselanjar tak? Berterusan tak?
Tak.
Yeah. Okay, you can see clearly here the one moving up for positive infinity and this one moving down negative infinity. So this is not, we call the limit does not exist and the function is not continuous at x equal to 2. Okay. Okay, find the value of k if fx is continuous at x equal to 1. So guys, girls, look at this domain, x greater than 1 and x less than or equal to 1. And this is for kx squared minus 2 and this one is 2 minus x. So when x approaching to 2 from left and x approaching 2 from right. Okay, now the condition syarat untuk the function x continuous at x equal to 1, we must make sure that the limit of x approaching to 1, okay, x approaching to 1 from left equal to the limit of x approaching to 1 from right. So my question to you, when x approaching to 1 from left, which function that related to this? When x approaching to 1 from left, which function that related to this?
2 minus 1. 2 minus x.
Okay, this is okay. 2 minus x. Thank you very much. And when x approaching to 1 from right, which function are related to this?
Kx squared minus 2.
Okay. Kx squared minus 2. Okay. So substitute x with 1 and 1. So 2 minus 1 equal to k1 square minus 2. So 2 minus 1 equal to 1. 1 square is 1. K minus 2. Then k equal to 3. Okay. K equal to 3. So let's rewrite this function, which is 3x squared minus 2 for x greater than 1 and 2 minus x for x less than or equal to 1. Okay, as you see a screen here now, f1, so limit x approach to 1 there here. So k equal to 3. Find the value of k for this one here now. Okay, x squared minus k squared. X squared minus k squared, that we can simplify this as an x minus k and x plus k. So then hx is continuous at x equal to t, x equal to k, and hk equal to 6. So then cut between these two, then we get x plus k here. So k equal to 3. Okay, dah hampir pukul 11 dah. You all pun mungkin letih dah esok kelas lagi. Saya cuba lajukan lah. Okay. Okay, now divide this into 3 sections for x less than or equal to 3, and next domain from 3 until 5, and x greater than or equal to 5. So for this domain is for ax squared plus 2, and the domain for 3 between 3 and 5 is for bx plus 1, and here equal to 4. Now, find the values of a and b if function is continuous at x equal to 3 and x equal to 5. So if this function is continuous at all from here to here to here, dia bersambung, berterusan. So limit x approaching to 3 from left, which is ax squared plus 2 equal to the limit of x approaching to 3 from right. And it is for bx plus 1. And then when x approaching to 5 from left, where for bx plus 1 equal to the limit of x approaching to 5 from right, and it is equal to 4. So substitute x with 5 here. 5b plus 1 equal to 4. Then 5b equal to 4 minus 1 equal to 3. Then b is 3 over 5. So when b 3 over 5, substitute here with 3 over 5. Okay. Substitute x with 3 here. 3 square equal to 9. 9a plus 2 equal to 3 with 3 over 5. 9 over 5 plus 1. Then find out what is the value of a here. Okay, there you go. Okay, kamu salin je lah. Saya rasa tak perlu saya perangkan panjang sebab dah pukul 11 you all pun mungkin dah letih dah. Ada yang menguap dah tu. Okay. Boleh ya? Okay, so for this exercise, which I think that all of you may try on your own. And if you have any questions or you cannot solve all this exercise, then bring up during the tutorial. Okay. Which I think that I'm not going to give you the answers or the solution for exercise. You should try it on your own. Okay. This one here. Okay. Guys and girls, that's all for today. Thank you very much. I'm sorry for taking your time for this night. Left and right, the same values here. Yes, okay. Thank you. Okay, so till we meet again, tengok dah daripada tadi berapa puluh orang tinggal 17 orang je. Tak apalah. Okay, so I'm going to put these videos of lecture part 3 and 4 in my YouTube channel. So if you like to look back and recall the solution or the explanation, you may refer to the videos then. Okay, so that's all for today. Thank you very much. Till we meet again. Have a nice rest. Okay, take a rest before the class tomorrow. And we meet again in the class. Jumpa di kuliah esok. Don't forget. Okay, that's all. Don't forget for our meeting and dating then. So that's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.
Thank you,
Thank you,
sir.
Go. Thank you.
Thank you, sir.
Hujung-hujung dengar thank you,
Thank you,
sir.
sir.
Okay, welcome.